Okay, so all right, it's recording now. Okay, good afternoon. This is week number 3. We're having another lecture. But before we start the lecture, I just like to inform you that yesterday I had a meeting with the Deputy Dean Development, Architect Sali, Dr. Raha as well, okay, from Building Surveying Department. Basically, for your information, we have already formed this task force, okay, to look into the certification of our Mercu Alamina building um, with through the GBI, okay. So our aim is to get the GBI certification sometime next year, and then you are involved in it lah. You are involved in it, and then your involvement is pretty much to look into the draft analysis of the building, okay. So the outcome of your involvement will be there are two things, okay. If you look carefully into the assignment deliverables that I've already posted onto Spectrum, kan. First of all, you have the coursework, which is a series of diagrams, right? That one is due in at the end of this year. And then another one is the essay, all right, which is a full report. In the full report, there are a few things which you have to include, namely the justification, the analysis, the precedents, right? And then the proposal, of course. And then also included in that is the ROI, return on investment calculation for the proposal. And then last but not least, on the same day of the submission of the report, of the essay, you have to do the presentation. Having said that, in order for us to proceed with the GBS certification, you will have to produce a draft GBI submission report. Okay. So what we need you to do is, based on the essay and also the work that you have done, you are to create the GBI certification report, the draft. Okay. So in order for you to do that, I'll be getting a number of samples, okay, from Architect Sali, samples of the GBI submission documents, and then I'll be sharing that with you, and I'll be also tutoring you how to use there's a BEIT tool that you need to use in order to calculate the BI, OTTV and whatnot, okay, especially for those two groups that have to work on the energy efficiency, okay, within the GBI. And then also you will be having crates along the way with Architect Michael Cheng and also Architect Sali and also Dr. Raha, okay, from Building Surveying, to look into the applicability of your report. In terms of marking or not, it's just totally myself, okay. Tapi for the report, the marking for the essay, the diagram, whatnot, semua is totally just for the course. Tetapi to ensure your involvement into the whole thing, the report for the GBS submission is to be submitted, either at the same time with the essay, ataupun perhaps we'll get it submitted perhaps 2-3 weeks after that lah. We'll see how it goes, alright. Cumanya I just need to remind you about that lah, otherwise I don't know, I don't want you to sort of macam suddenly you found out oh no, there's a new requirement. This one is actually part and parcel of the whole thing, okay. So at the end of the day, you'll be seeing your work being used for actual certification work, okay. We've already secured ourselves some funds in order to do that. We also have got all the consultants ready, to be involved with the project. So hopefully this time next year we'll get at least GBI certification. Otherwise we can do better, we get silver, better lah. So your proposal could be a reality lah. By the time you get into your design thesis, you get to see that our building will get certification, insyaAllah. Okay, so we'll try our best for that. Jadi hopefully you can do a good job lah. I will also share with you some past assignments which has been done by my students from UMPDEC, which is engineering. Okay? So these are non-architects, non-built environment students at all. They're all science or engineering based students, and then they've done some really good work in analyzing a number of buildings, commercial buildings, okay, using GPI, and then coming up with a report. Some really interesting proposals as well, and then really good return on investment calculations, okay. So I'll share those with you later on as well. I'll put up a Google Drive instead of Spectrum, okay, because the documents are quite large. Jadi, later on I'll share it with you. You can have a look at that. But for now, have you divided all yourselves into the number of groups that are needed? There are 6, 7, 8 groups. Do you have all the groups now? I can see
yes.
some, I can see some movement dalam in the WhatsApp group, but there's no definitive answer there. So you have 8 groups now? Huh?
Yeah, we have 8 groups.
Okay, good. So later on, you have to start working on it lah, okay? Therefore, I highly urge you to look up into Spectrum and then read up about GPI straight away, okay? Without waiting for my lecture. And then somewhere along the way, we'll be having a talk by architect Michael Cheng. Actually, the actual audience is to be year 5 students. But I would like you to join in as well, because it will be really useful for you, okay? So that you get an understanding, better understanding of what designing a green building is all about, okay? So we'll have that. So for that talk, ada architect Michael Cheng. We also have hopefully a really prominent engineer who's been involved in all the early showcase green buildings in Malaysia, okay. So he'll come in as well. So two really prominent people talking about green buildings very soon. Hopefully in the next 2 weeks or 2-3 weeks, okay. So that one we're working on it online, and then perhaps it will be done on if I'm not mistaken, it's on a Wednesday, okay. So let's see how it goes. Usually Wednesday, you guys don't have any classes, can? You don't have any classes, isn't it, on Wednesdays?
No, we don't.
Okay.
No.
So hopefully you can keep your timetable open in the next 2-3 weeks. Okay. Let's move on to the lecture. Today's lecture is about building energy consumption and energy audit. Okay. It's something really important as well. Oh, before I forgot, one other thing that myself discussed about with the Deputy Dean yesterday. For your assignment, some of you might need to get access to the faculty even now, okay? So myself and Architect Sali, we've already helped you out in terms of getting information about water lah, and all the other documents as well. So we'll be compiling the documents like energy documents, and then we've also verified that we already have a water meter, and then we are getting the BQ, the bill of quantities for mature alumina building. And then we'll be getting the drawings for mature alumina building as well. So everything will be put into the Google Drive. I'll be sharing it with you, together with past reports and also samples of GBI reports, okay, submission reports. So in terms of getting access, I would like to get at least one person from each group to give them access to come over to faculty, especially those who are living in KL and Selangor. The closer you are to the university, the better. So you volunteer yourself to come to the university. We'll put out a letter for you so that you can come along and verify a number of physical things that are on site on campus. So you can take photographs, you can do some measurements, you can do whatever that you need to do in order to get your assignment done. So if you can organize that, get a couple of names from each group ataupun one person saja pun tak apa, up to you, alright. And then just forward the names to me so that I can get you access. Okay, I think you better do that very quickly lah. Try to organize that within this weekend, and then hopefully sometime next week we'll get the letter out. Then you get access to come in and do your assignment. Okay, because sometimes you may also need to go to the library as well. There's certain things that might not be available online through our digital repository. Okay, so you might want to come over to the library and get your information. Jadi it's best if you name that person. Okay, more than one, okay, but not more than 2 persons per group lah. So I'm looking at easily 2, 4. There's 6 group, 12 plus 2 more, 14. Okay, so 14 students. I think that's maximum lah, nothing more than that. Okay. So let's go into the lecture. So the rationale behind this topic is about the balancing act between two things: environmental protection, conservation, against the social and economic demand. Okay? Whether we like it or not, sustainable development too is an oxymoronic kind of term. And on the one hand, you're promoting development, but on the other hand, you're also promoting environmental protection, right? And then, but ultimately, it's all about economic gains and also social kind of welfare. So very hard to balance out all these items. So on one hand, you have issues, environmental issues such as loss of lives and property. Okay, so you probably read in the news about the typhoon in Vietnam. The same typhoon which has caused the wreck of Dayang Topaz, the ship in Kuching. And then the same typhoon which is wreaking havoc in the south of Mindanao right now. But in Vietnam, a number of people were killed. I think about 50 people already killed because of landslides caused by the same typhoon. And so you get loss of lives, and it happens every year. Not one but many people die because of climate issues, right? And then at the same time you also have property losses. So together with the landslides, you lose lives, you lose properties as well. And then losing property has happened in Malaysia as well. For instance, like on Cameron Island, I think mentioned previously, the same river which is flowing through Tanah Rata there have caused. I've gone through flash floods before, and really big flash floods. In the last few years, there were a couple of flash floods. I think 2 or 3 people died, and then many properties were damaged, right? And this is on top of the environmental pollution, the pollution of the river by the vegetable farmers. And then, if you go way back in 2014, we had the massive floods in Kelantan, Terengganu, and Pahang, many lives were lost. Countless numbers of houses were demolished, right? And then even small towns were wiped out of the map altogether. For instance, like Dabong in Kelantan, it sits right in the middle of, beside the Kelantan River, at the bend of a Kelantan, at one of the bends, right? And because of the floods simply just washed out the whole town, totally wiped out, together with all the major bridges connecting the town. Tragedy, of course. Okay, so we have ourselves experienced this, not just other countries. You go to the Philippines, I think 2-3 years back, you had the big typhoon. Thousands of people were killed. And this is natural, of course, but this natural occurrence has been exacerbated by the increase in temperature that we have in the environment. Okay? Therefore, you have a lot more collision between cold and hot winds, flowing within the Pacific, creating a really chaotic microclimate there, okay? Creating more typhoons. So it's becoming more and more dangerous, okay? And at the same time, because of the rise in the sea level due to the melting of ice of glacial ice, we are experiencing more high tides, so seawater going into our dam and then causing floods and whatnot. Okay, so problems, right? And then this is all testament, I mean to say evidence of the global climate change. And then at the same time, because of global climate change as well, you would witness the extinction of some flora and fauna, in your lifetime. In my lifetime, we've already seen a lot of different kinds of animals which are extinct. The latest one in Malaysia, perhaps a well-known one is the rhino, the Malayan rhino, totally extinct. The last one, Puntung, the name, already died. And there were only 3 of them. All of them have died. And then, the Malayan tiger as well. How many left? Very few left in the wild. Up to the level that the Sultan of Johor made a warning. I think about a couple of weeks back, there was a sighting of a number of wild Malayan tiger by the riverside in Kota Tinggi, made a comment, saying that if you go and hunt all these tigers, it will hunt you again. It's up to that level. It's desperation. And then at the same time, because of climate change as well, the climate is becoming warmer and warmer. Too much more precipitation and rain and whatnot. So we'll be losing a lot more plants and trees as well. Okay. So and this is in the context of social and economic demand, whereby we have to increase the amount of manufacturing, to increase the amount of jobs, to increase the amount of profits that we get, okay, in order to pay for taxes and whatnot, to look after the social welfare of people. So, at the same time, because of this, you get more transport, more cars, more buses, more lorries on the roads, right, to transport things, to transport people. Is inevitable, technically. And at the same time, more houses, more buildings, more offices, you have to generate a lot more electricity for this. And in order to generate a lot more electricity, you either build more hydroelectric dams, or you build more coal power plants, or perhaps go into something a bit greener, which is like solar power plants. But having said that, solar is really slow to catch up. And then at the same time, you're operating all these buildings. Operating buildings will definitely entail energy usage, a lot of energy usage, and then a lot of water usages as well. And then along the way, you will have a lot of wastage. So problems. So balancing out all these items is challenging. So right now, even though this data is a little bit old, but nevertheless, for Malaysia, the commercial residential buildings account for about 13% of the total energy consumption. All right. And when I say energy, it means that it's a compilation of electricity together with gas, together with other things. And then, at the same time, in terms of electricity, nearly half of it is consumed by commercial and residential buildings. The remainder is by industrial buildings, by agricultural buildings, and other types of buildings. Okay, so but the scale is tipping towards more than 50%. So therefore, we architects have a lot of role to play here, a big role to play, whereby we should be able to at least design buildings which limit the amount of electricity consumption at least. Okay, so buildings which are more efficient, buildings which are cooler, buildings which are, which uses less amount of resources, so on and so forth. There's so many things that you can do, in fact, as architects. And I know even though, even for older buildings, you can still do a lot of things to older buildings and turn them into green buildings. I mentioned last 2 weeks that any building, you can turn them into green buildings, you can turn them into intelligent buildings. You need to install a certain amount of, perhaps change some materials in the building, perhaps install some technology into the building in order to make sure that it's energy efficient or water efficient, right? So there are things that you can do. And then, considering our climate, the consumption usage is pretty much can be broken down into a number of items. The biggest culprit here is definitely air conditioning. Air conditioning and cooling. Okay, air conditioning and cooling. You mean to say your air conditioning, your refrigerator, your freezer, right? They all account for about 60 to 70% of your energy consumption, of your electricity consumption, which is a lot. So when you receive your electricity bill per month, when you look at it, the amount of kilowatt hours that you use, let's say 400 or 500 kilowatt hours per month that you use, about 60% of that is directly connected to cooling. Okay, so if you can use refrigerators or freezers which are 5-star rated, let's say, that will definitely reduce the amount of electricity that you consume. If you reduce the amount of times that you open your door, your fridge door, then that will definitely reduce the energy consumption, because every time you open it, the fridge will have to, once you close it back, the fridge will have to cool down again to a certain temperature, isn't it? Perhaps you have to set your temperature inside the refrigerator to a bit higher, rather than putting it at 16 degrees, perhaps you increase it to about 18 or 20 degrees. The food will not deteriorate so much even at 20 degrees. You've put it at 16 degrees, after a little while, your fruits and whatnot will definitely freeze up. And then, you know, your freezer, you don't have to set it at -5. You know, you can set it at -3 or even 0 degrees. If you can do that, it'll be great. Especially if you have refrigerators, which is slightly more expensive, then definitely you can control temperature really well. But there are some cheaper options out there, you know, a 2-star kind of rated equipment, or even 1-star equipment. For those kind of bit harder for you to control, but nevertheless, kind of depends on where you locate it as well. If you put your refrigerator in a very hot place, meaning to say it's a location in your kitchen which is really illuminated by the daylight, you know, by the sunlight, it becomes warm. Or perhaps it's too close to the cooker, also very warm. So, you know, your compressor will have to work more. So, you know, an easy thing to do is just to relocate your fridge or your freezer to a location which is a little bit cooler, you know, shaded, and well ventilated as well. That will really allow your refrigerator and freezer to reduce less amount of energy, like electricity, to work. And then besides that, air conditioning, of course, you need to look into how you use your air conditioning. Okay? You don't just switch it on 24 hours a day, every single day, and then running at 16 degrees and full fan capacity. You reduce it. Okay, you can change the settings. You know, for instance, I've also learned this a little bit. You know, right now, if you look at my, you can just about see the ice icon up there. You know, for this one, it uses a bit more energy to run. But if you change the mode to this one here, the water drop, that will reduce your electricity consumption directly by at least 25%. It'll still be cold, your room still be cold enough. The air conditioning will be maintaining a certain relative humidity within your room, but it doesn't have to really freeze up the room, you know, in comparison to the other setting. So it's just a matter of pressing a button to change the setting. So running at 25, running at 26, you know, if it's cold, too cold, running at 26 or 27 degrees for that matter, run it at the water drop setting, right? But if you don't feel comfortable, you change it back to the ice setting, and then later on, once you're comfortable enough, you change it back. So you have to be a bit more active when it comes to changing your aircon settings. And then make sure that your rooms are tight. You know, when you see the windows are tight, you don't lose all the coolness. And at the same time, you know, perhaps draw the curtains, you know, close the curtains, draw it, close it. That will limit the amount of daylight coming in and heat together with the daylight, right, the sunlight. So the aircon should be able to work at a better efficiency. And then, you know, if you can make some changes to your air conditioning, and usually the aircon has got 2 units, you know, one is you have the compressor outside. You have the diffuser inside the building, right? So relocate the compressor, which is sitting outside, to a location which is shaded. Otherwise, if you can't, you just put a small awning over it, or put some shading over it, or perhaps plant a tree or something, you know, or put a pot, you know, a series of potted plants close to it, just to shade it. The idea is to, once you provide shade, 2 or 3 degrees lower there, so the compressor will do not have to work so hard in order to cool down the space. Okay. So by doing some small things such as what I've suggested earlier, you know, will definitely reduce your cooling load tremendously. You don't even have to go and insulate your building. Just make sure that, you know, your doors are tight as well. Now you've got some plastic strips under your door, or you simply just put a towel there. Easy. Okay. So and then besides that, you've got lighting. Okay, artificial lighting accounts up to 30% of the total building load. It's a lot, but you know, lately, because of the advent of LED artificial lighting, okay, this percentage has gone down considerably. So now we're seeing only about 10% to 15% of the total amount of electricity that you use is attributable to daylight, to artificial lighting. To me, you know, spending a bit of electricity on artificial lighting is almost like lesser of the two evils in comparison to air conditioning. air conditioning is a necessity. Artificial lighting is also a necessity. But you can always just draw the curtains, switch on the light, and then use less energy to cool down the space. Or you can also open the curtains, right? Let all the daylight come in. You switch off all the lights, but you might need to increase the capability of your aircon. So you might have to turn the aircon up in order to cool down your space even further. So you choose. You are the user, so you have to choose which one you are comfortable with, okay? And then experiment with it and see how it goes. So you can experiment it with yourself at home, okay? See, and perhaps that will lead towards a positive outcome, okay? So for daylighting, for artificial lighting, if you still have got the old incandescent lights, or even fluorescent lamps, go to Mr. DIY and just buy new LED lamps. Easy enough to fit. Even the old fluorescent light casing can still be used with new LED light bulbs. But you need to disconnect your ballast. Okay, so either you do that or just replace the whole thing, and it will still cost you less than 30 ringgit per unit. Okay, the body of the casing together with the LED light, extremely cheap nowadays. Okay, a long time ago, let's just go back about 10 years ago. Okay, 10 years ago, you will be hard pressed to find an LED light which is lower than 50 ringgit per unit. Very, very expensive. And then the only ones which were available then was Philips, and they only had bulbs rather than the long fluorescent type kind of light bulb. So it was not very useful. Still expensive. But now, because of demand and the market and trade and whatnot, so the prices have gone down considerably. So you can change it. You don't have to really rely upon old light fittings anymore. Even the old yellow light fittings you can change them to LED ones which are which have got lower wattage with yellow color light. So you've got warm white, and a few other types of LED colors nowadays, right? So there's a lot more choices now. Meaning to say, you should not be relying on the old technology anymore. You can save your electricity very easily, on daylight, on artificial lighting very easily. So you have to start doing that, lah. And then the next one is all the other equipment, the computer, laptop, your hi-fi, your video, whatever, okay, handphones and so on and so forth, you have a lot of items in the house, a lot of items. Some of these items will probably use more electricity than others, okay? For instance, like the kettle, okay, the cooker, the oven. The oven especially uses a lot of electricity. Your dryer, your washing machine also uses a lot of electricity. So all you have to do is just first of all get the best rated equipment, 5-star, 4-star. If you can afford it, great. If you don't, then you look into how you use it. Okay, so perhaps if you don't use it so much, then it's okay. But if you use it every single day, let's say you bake a cake every single day, then yeah, you would probably that will probably inflict a lot of electricity usage at the end of the day, lah. But because of your hobby, you have to do it. Perhaps you look into a better equipment, or perhaps you look into cooking it in a different manner. But you do the change if you need to. Okay. Besides that, kettle. So don't don't boil only a cup full of water in your kettle, lah. If you can, you boil the kettle with a full kettle, okay? Fully loaded kettle, and then you fill up your thermos afterwards. It's more efficient that way. Okay. So there are many ways that many things that you can do in order to save electricity here and there. But at least you get to see the biggest culprit. It will always be cooling. And then when you look at our electricity tariff, even though this is quite old and TNB has already updated this very recently, only one time. But even after the update, it is still very, very cheap in comparison to others. Okay, Indonesia, this is quite old, but now it has skyrocketed. It's as expensive as Singapore and Philippines now. So even the really disadvantaged, a lot of disadvantaged people in Indonesia right now, they have to pay steep prices for electricity, but somehow rather they're surviving. How is that possible then? They even pay more for their petrol at the gas pump in comparison to us, but still they're surviving. How is that possible again? Huh? Whereas here in Malaysia, whenever the prices of fuel go up for a certain amount of cents, if it goes up like 2 or 3 cents or 4 cents, nobody will complain so much. But once it goes up 10 cents and even more than that, then you will complain a lot. Okay. But still, our petroleum prices are a lot cheaper than anybody else in the region. Okay. And then at the same time, our electricity tariff is also a lot cheaper than anybody else as well. Yet, we do get a lot of complaints. And then, if you look at the throughout the period of the MCO, naturally lah, when you stay at home more, you use more electricity lah, so your electricity bill will definitely increase. But somehow other people cried foul and thought that, TNB has already charged them over and above what they're supposed to be charging. It's not fair and whatnot, okay? But they have to look at themselves. They are the ones who use electricity. Just pay whatever you use, isn't it? So if you go to the shop and got yourself a plate of rice with a piece of chicken and a piece of sotong, then you pay for it lah, Otherwise, put the sotong back and then just pay for the rice and the chicken, kan? That's what I'm trying to say lah, So if you use something, you pay for it. And this is in context that our electricity tariff is still very, very cheap in comparison to others. So we should not be complaining so much. Somehow or other, there's a lot of subsidies being given lah, For your information, TNB gets a lot of subsidy, from the government to pay for the coal that they purchase from overseas to burn in order to generate our electricity. See, that's the context, right? So they're not really paying market price for the coal. They're paying something cheaper. They pay market price, of course, but they get rebates from the government, of course. So technically, it's cheaper. And then they burn it. They're selling it to us. Okay, so they still make a lot of profit. TNB is one of the richest companies in Malaysia right now. Okay, which is good. At least we know they're rich. They should be able to improve themselves and upgrade the equipment and whatnot, to make it a lot greener, which they are doing right now, which is good. But having said that, we're still relying a lot on coal. We're still relying a lot on diesel. We're still relying a lot on other means of energy resources which are non-renewable. Okay, and then our hydroelectric dams are only providing about 25% of our electricity, which is still very low. Only a quarter, right? And then biomass is really, really far behind, not even 5%, about 2% right now. So solar is catching up, but still very, very low. Okay. But nevertheless, we are still burning a lot of non-renewable resources in order to meet our energy demand. At least we know that we're not going to get any electricity cut off and whatnot, because our reserves are quite high, okay, more than 20%, which is good for the fast developing countries such as ours. Okay, so you can easily industrialize and add more industrial facilities around the country without affecting the energy supply side so much. So and at the same time, we have a lot of stability when it comes to our electricity tariff, so we can expect to get the low prices for quite some time yet. And then the government has been really kind, in giving rebates and giving some discounts. People got a lot of discounts. Now if you use up to 600 kilowatt hours per month, you still pay very low amount of bills in comparison to previously, right? But it means that it has reduced further the tariff. So either it's a good thing or a bad thing, though I'm not sure, I reserve the comment, To me personally, if you have to really educate people about not wasting electricity, you're gonna have to charge them, right? If it's expensive, definitely they will not waste. Unless you live in excess, you have a lot of money, you don't know what to do with the money, then fine, But normally, if something is expensive, you will not waste it. But something when it's too cheap, like our electricity and our water, you will waste it. Okay? Nowadays, water, yes, we have a problem. It's cheap, but at the same time, you know, the supply is not reliable. But that one is a totally different topic altogether, lah. Okay. For electricity right now, it's cheap, and then we're using a lot of items at home, and then technically we're wasting a lot of energy, lah. Let's put it that way, lah. Okay. And there's a lot of wastages. It's too cheap. Something has to change. Okay. And then, but the good thing is, you know, at least we know for architects, we can sort of easily predict, you know, the kind of building that we have to design, because we live in an environment which is quite predictable. Okay, our climate is quite predictable. Tropical, you only have rain or dry seasons, right? And then, you know, it becomes really hot, it becomes really wet. We don't really get a lot of winds, a little bit of typhoons here and there, but not so much. Okay. Even our monsoon seasons kan, our monsoonal winds kan, is directional, of course, and it's predictable, of course. You know, within a certain part of the year, it's blowing in a certain direction. In another part of the year, it blows in the opposite direction, and then in between, you get a lot of unsettled weather. So a lot of rain, a lot of storms in between. So quite predictable. It's not that we have winter or summer or, you know, autumn and spring kan, you know. But at least it's more predictable, easier to predict. And then at the same time, because we are located very close to the equator, the sun is almost directly above our head all the time. It's only about 4 degrees saja kan, you know. So the solar angle is very, very shallow for Malaysia. For Singapore, even more shallow. Okay, so when you design something, a roof, let's say, you know for sure the roof at whatever angle will get illuminated by the sun very easily. Okay, so there's not a lot of shading unless you get shading from big trees or big buildings around you. So, you know, your roof becomes really important. You know, you have to insulate your roof. If you use a certain material for your roof, you know, let's say clay tiles or cement tiles or, you know, or metal deck or whatever, you know, you have to insulate them underneath in order to make sure that the roof performs better, right? If you don't insulate, you will allow a lot of heat to go in. Definitely. Okay. Perhaps, you know, you use different kind of materials which are not conductors of heat. Perhaps you go and use onduline, let's say, you know, something like that. Or plastic, why not? Or glass, but glass allows a lot of daylight to come in, you know, so you have other problems. So, but at least, you know, it's hot and humid, very predictable. Okay, and then there's the monthly temperature variation is quite small as well. So we know that the temperature will be hovering between 32 and 36 degrees, or, you know, slightly thereabouts technically. And then, you know, the variations every single day for one whole month is about 8 degrees only, so very small. Whereas if you go to the Middle East or somewhere in the middle of Australia, you know, you get daily temperature differences of about 20 degrees or more, right? So during the day, it can go up to 50, 60, 50 degrees centigrade. At night, it goes down to 0 or even minus something, you know. So the temperature difference is great in comparison to where we are, okay? So the mean daily temperature over here, the hottest one is about 27.8 degrees only. That's the average lah, right? Whereas, you know, if you go to other countries, the hottest could be a lot lower than this, you know. You go to New Zealand in the middle of summer, the hottest temperature will be 21 degrees, which is really pleasant. You know, can wear a t-shirt, you can walk around in your jeans and whatnot, you know. But once in a while, you still get some wind chills. So you have to get your jacket ready. But when you go into winter, the temperature will be around hovering, you know, at the region of -5 or 10 or 0 degrees. Really cold all the time. Whereas our coolest is only about 2 degrees lower. So the coolest month is always December. The hottest month is always around February or March. It shifts in terms of days, but it doesn't shift in terms of months. So you can expect the hottest month should be around March. And then, you know, the coolest month should be around December. If you ask me why, you know, perhaps it's because of the monsoon, And then the daily temperature exceeds the value of 25 degrees or more 50% of the time. So when you say if you record your temperature throughout the whole year, 50% of the time it will be more than 25 degrees. So you only get 25 degrees perhaps at night. Very early in the morning, it will be around 25, 23, 22 degrees, and then suddenly it will go up and up and up until 32 degrees, 33, 34 degrees every single day without fail. Okay. And then the monthly humidity always exceeds 70%. So relative humidity is read in terms of percentage. Okay. So in an office building, you want it to hover between 45 to 55 percent. Anything more than that will be a bit too damp. Okay. Anything lower than that will be too dry. Your mouth will start to dry. Your eyes will dry up. Your nostrils will dry up as well. Okay. So you need to get a balance somewhere. So your air conditioning just now, you set it to a certain temperature and certain kind of mode that that will allow for about 50 to 60% of humidity in the room. Once you go out of your house, usually our humidity will be within 60 to about 90% every single day. Okay, it might not drain, but the humidity level is still very high, 70+% usually. So that's the reason why you perspire a lot. It's a lot. You perspire a lot. Banyak berpeluh. Too much amount of humidity outside, right? But it's something that we cannot run away from. That's what it is. So high amount of humidity. Okay, and then the wind speeds are quite low as well, which is a bit strange because there's a lot of coastal areas in Malaysia. If you go to the coastal areas, yes, you might get some wind there. But in big cities such as Kuala Lumpur, where we are at right now, you don't get a lot of wind. If you do get winds, it'll be really high up, really high up, 20 floors or more. Then you can feel the wind. Down here, you don't feel it so much. There's a lot of obstructions everywhere, and then at the same time, the prevailing winds, you only get two directions pretty much, northeast and southeast, east and southeast. So in Sabah and Sarawak is slightly different because primarily the monsoonal kind of direction would affect Peninsular Malaysia and large part of Sarawak. Okay, Sabah is slightly off. Okay, it's pretty much affected by some wind systems which are really dominant in the seas near the eastern side of Borneo there, and also southern side of Mindanao, kan. So slightly different kind of system, but nevertheless, they still get a bit more wind as compared to Peninsular Malaysia. Therefore, that's the reason why when engineers have identified the best location to do harvesting of wind to generate electricity, only a couple of places in Sabah came up, which is Kudat and also Kudat and I think Kudat and Sandakan, if I'm not mistaken. There are a couple of locations in Sabah. Because of the location, near the coastline and also located within the wind system, which is slightly different from the one that we get in Peninsular Malaysia. Whereas here in Peninsula, if you set up a wind farm, you won't be able to get enough more electricity. You'll be investing too much money for something relatively very small. So previously people have set up some wind turbines. They've done it many times before. They have managed to get some electricity out of it, but they've not been able to generate enough electricity to justify going big and investing into a farm, like a solar farm. Okay. On the contrary, if you do open up a solar farm, you will be able to get enough, not just enough, but a lot of solar illumination very easily. And then you don't even have to go and install those solar farms which have got automatic systems that track the direction of the sun. And you don't have to, because most of the time, even though at a slight angle facing south, of course, you will definitely get enough enough illumination throughout the whole day to generate enough amount of electricity, okay, to justify the economic investment that you put in. So and then at the same time we do get a lot of rain, and that rain washes up all the solar panels, clean it up regularly. Okay, that makes it even better, isn't it? So our rainfall is also quite heavy. One of the wettest places on earth, technically. There are a couple of locations within Peninsular Malaysia which is so wet, like Gunung Jerai, one of the wettest places on the earth, technically. And then, if you go into Sabah and Sarawak, there are a couple of places there as well, which are considered as one of the wettest places on earth. So, yeah, these are the pretty much the bottom line of our climate. And then in terms of thermal comfort, okay, there are a number of parameters that you need to remember. Okay, usually for thermal comfort, in order to get thermal comfort, the temperature range will be around 23 to 36 degrees centigrade. Okay, anything less than this will be it will be too cold. Anything more than this will be too warm. Okay, having said that, there's a number of studies which have shown that people in Malaysia are able to tolerate up to 37 degrees. Okay, 37 degrees. You go 28 degrees, is you start to feel a bit of perspiration in your neck, right? So somewhat other, 27 and below is okay, but once you go 22 degrees, it's just too cold. You start looking for a jacket, or you probably want to open up windows and whatnot. So, and then there's also a difference between the genders. Okay, there's a number of studies saying that women can tolerate colder temperatures compared to men. Somewhere that's the case. I'm not sure why. I can't really tell you physiologically. Yes, there's a lot of difference between men and women, but nevertheless, some or other the women can tolerate lower temperatures. So this is coming out from a number of studies, which study officers, office workers. So in offices which are colder, women tend to produce better work, more work than men. But having said that, women are a lot more diligent than men. Anyways, I'm being sexist here, but nevertheless, that's what it is. So, but there's a lot of studies on that. Okay, and then relative humidity, we can expect thermal comfort if it's ranging between 40 to 70%. Anything less than that is just too dry. I mentioned earlier, your mouth, your eyes, your nostrils become dry. Anything more than that is just too wet. Okay, so again, you perspire at the same time. In an office environment, let's say, if you get 90% relative humidity all the time, your paper will crumple up very easily. It's not going to be nice. And then you do not want to work in a wet environment as well. You want it to be relatively dry. Okay. That's the reason why if you take a can of Coca-Cola, let's say, a cold canned drink, put it on your table, right? Soon enough, not even in a minute, you will get to see a lot of water droplets on the can, and everything simply just accumulate at the bottom of your can, right? It shows the the humidity level in your environment. The indoor air quality as well. Okay, for air movement, you want it to be within 0.15 to 0.5 meter per second. Okay, you do not want it to be higher than that. If it's too high, then things will start to blow all over the place. Okay. If it's too low, it'll become stale kind of air. Okay. The MGTC building, Malaysian Green Tech Corporation building in Bangi, although it's hailed as one of the greenest buildings in Malaysia, okay, it's a showcase building. It doesn't have any air conditioning. Okay. It only has got this underfloor cooling system, which works fine. Okay. But the problem is, although it absorbs much of the heat from the people and the buildings and whatnot, having said that, there's no air movement because they don't have a blower, to blow cool air all over the place, like the air conditioning, like the ceiling fan. So at the end of the day, a bunch of people, started complaining, and it was not very comfortable. So they had to introduce fans, table fans, in order to get the air to move. Right? By having air movement, then only you get thermal comfort. Okay. Other parameters that you need to remember about, let's say, carbon dioxide, anything more than this becomes toxic. Remember the tragedy, the four friends in Sabang Pride, and they all died except for the driver, of course, because of carbon monoxide inhalation, isn't it? So you have more than 10, it's absolutely dangerous, because carbon monoxide, what it does is to stop the lungs from taking on board oxygen, okay, rather than it sticks, carbon monoxide sticks to the it doesn't allow for oxygen to be absorbed by the body lah. So you'll be suffocating slowly. Formaldehyde, particulate matter, more particulate matter in the air becomes dusty, not good enough. And then volatile organic compound, the smell that you get from new carpets, the smell that you get from new furniture and new cars, whatnot. This is what we call volatile organic compound. Some of these VOCs are poisonous. Some of the VOCs are not poisonous. So nowadays you get to see paint manufacturers like Dulux or Nippon Paint, they've been producing non-toxic VOC or no VOC paints. So there are no smells coming out from the paint. It's kind of good, okay? Some people do get attached to it, but nevertheless, no smell from the paint is much better lah, because it's not toxic. At the same time, you might get the same kind of VOCs from laminated timber floors, from many other things as well, especially from something which has got adhesives. So adhesives will emit a certain kind of smell, and that smell is VOC. The less amount of that, the better, okay. And then in terms of lighting, you want to keep it between 300 to 400, and this is pretty much applicable to offices, to schools, to universities, For homes, you can lower it down to even 100 or 150 lux, okay? Because it doesn't have to be so intense in terms of artificial lighting. By doing so, you will reduce your lighting bills as well, okay? But for offices, you have to be bright enough. But if you work on computers like what we are doing right now, you get some illumination from your computer anyways. So you can dim down your light if you can, right? And then in terms of acoustics, you need to keep it between 40 to 50 decibels, okay, nothing more than that. If you go beyond that, then it becomes too noisy, too low, then it becomes a dead space, it does sort of affect your mood as well, So in terms of energy efficiency, there's so many things which are connected to it, to help it out in Malaysia. For most, we have standards, of course. We do have the MS1525, although it was drafted and released in 2007. I already shared it in the Spectrum page. Okay, ada dekat situ. You can download it, you can read it. Okay, the MS1525. It's the Malaysian standard for energy efficiency for buildings. So there are quite a number of stuff in there that you need to know, and perhaps if you can implement in your own design, even better. And then in the context of our assignment as well, if you can meet those requirements or exceed it, it'll be even better. And then the GBI is of course based on that. So the MS1525 is a really important document. Okay. So there are many things in there, daylighting, acoustics, in terms of temperature, so many other things as well, to lead towards energy efficiency. Secondly, we have a lot of government acts, which has been passed in the parliament, to look into energy, in terms of electricity tariffs, in terms of electricity supply and demand, so many other things as well. Regulations, okay, rules and regulations. You cannot go and tap freely into the TMB line, okay. If you notice throughout the MCO, TMB has been really active in disconnecting many electricity thieves, okay. And then ironically, the thieves are a lot of industrial and commercial entities, and some of them are illegal entities as well. For instance, like online gaming Bitcoin peddlers, whatever lah. Okay, they install a number because they have a lot of electronic equipment that they need to run with a lot of electricity 24 hours a day, So in order to not pay the right electricity tariff, okay, electricity bill according to the right tariff, there's many different kinds of tariff, C1, C2, whatever, for industry and commercial entities. If you change the tariff bracket, you have to pay more. So for these people, they thought that, well, they can run away from paying higher electricity tariff. They simply just go and tap into the line manually by themselves, illegally. It's utterly stupid, one thing. Secondly, it's dangerous, right? If it causes an explosion, then a lot of people will die, of course. But a good thing is, at least there's a lot of investigation being done by TNB and the local authorities, and they've been able to root out all these people. So slowly, electricity theft has been reduced, within this year alone. And then there's a lot of legislations, of course, So in terms of policies, the country do have this energy efficiency roadmap, that looks into implementing many things, to get people, to get industries and commercial entities to go into energy efficiency, rebates here and there, so many other things. So one other thing which is a policy is also the 40% carbon emission reduction by 2020 per capita, which we have not achieved by any means. We have not achieved this. So the government will have to relook into this and perhaps come up with a different with a new pledge to reduce our carbon emission. Either it's per capita, if it's not per capita, it's okay. But nevertheless, a new pledge to show our commitment to energy efficiency and also reduction in carbon emissions. And at the same time, the Energy Commission, the government have produced this electrical appliances labeling program. So when you buy new electric products, some of them will probably have this star rating with a sticker at the back or at the front of the equipment. Some smaller items might not have the star rating. For instance, like toasters. Toasters usually don't have star rating. The other one is kettles, some other, they don't have star rating, even though they might be approved by SIRIM. SIRIM will only approve them in terms of safety, but SIRIM don't approve them in terms of energy efficiency. The energy efficiency side is looked at by, analyzed by the Energy Commission. So many of these companies, that manufacture a lot of these electrical items, they do not go to the Energy Commission to get the rating because they will have to pay more. So they have to pay for that service, to get the labeling. For much of the bigger companies, they do get the star rating because it's for labeling purpose. At the same time, it's for marketing. But definitely they can afford it, in comparison to smaller companies. So, and then there are a lot of products from other countries as well, which do not have any star rating at all. So something that has to be improved, Whereas, if you go to some other countries, let's say Australia, for instance, almost all of the items will probably have a star rating. Big items as well, big items especially, not the small ones. You go to Europe, they also have their own energy labeling program. America also has got their own. So it's a good thing, right? But when you look at the labeling, if you compare between the Australian, the Singaporean, the Malaysian, and also the European one, you will see a lot of differences in terms of the kind of information that is portrayed in the labeling. The one in Malaysia is very user-friendly, very easy to read. You have stars, of course, and you also have the amount of kilowatt hours that it uses for a certain amount of time. Good enough in terms of information. But when you look at the European one, it will give you even more information. Sometimes for some people it could be a bit confusing as well. But having said that, there's a lot of information there which are quite good. Okay, so as consumers, you choose whichever electrical item you want to buy. Okay, and then the next one is you have a lot of programs implemented by the government and many other agencies as well. You have incentives. You have the feed-in tariff, in terms of if you install solar panels, the TNB will pay you back with a certain amount of money, according to the feed-in tariff. Right now, the TNB through its one of its subsidiaries, they've been able to get, I think about I read this about 2 days ago. They've been able to get about 300 over companies and also local authorities and government officers in Malaysia to sign up program with TNB to install solar panels on top of the roof, okay, as part of the national kind of program to generate solar energy on the roof. And then the TNB will be paying them back according to the amount of usage, okay. So if they use more than what they consume from the grid, then TNB will not be paying them, they have to just pay their bills. But if they use less than the amount that they produce, then TNB will be paying them back. Because technically they are part of the national solar energy generation. And right now, that company, the subsidiary of TNB, has managed to install about 50 megawatts worth of solar panels. Solar panels have the capability of generating as much as 50 megawatts of electricity, which is huge, okay? So, but it is still a small percentage of the total amount of electricity that need to be produced every single day, okay? So, a lot more work to be done. But nevertheless, we're going in the right direction lah. Okay? So in terms of our energy generation mix, there are pretty much 6 items, 6 resources that we usually use. First and foremost, the biggest one is coal. Okay, so we have a lot of coal power plants everywhere in Peninsular Malaysia, Sabah and Sarawak. We have built new ones, of course. 2 new ones in Sabah. Despite the best wishes of despite the wishes of the people over there, a few years back, who do not want to have coal power plants, polluting their pristine air, suddenly now you have a number of new coal power plants in Sabah. Okay? Sabah is not under TNB, of course, it's under SASB. So Sabah Electric has gone down that route, okay, which TNB took, 30, 40 years ago. Rather than going for solar or something renewable or perhaps wind, which is abundant in Sabah, they went for coal, which is the cheapest option. I think perhaps they do not have the capability of investing a lot of money into solar, perhaps. I'm not sure that. But coal is the easiest one to use. Definitely went for that. And then the other one is hydroelectric, of course. So for Sarawak, let's say Sarawak has got Bakun Dam. Okay? Bakun Dam is covering, I think, easily about 40+% of electricity usage in Sarawak alone. Previously, Bakun Dam was designed to supply electricity for the whole country. And we were supposed to have this undersea cable connecting Sabah and Sarawak and Malaysia and the Peninsular Malaysia. And that project was halted, okay, right after Bakun Dam was completed about nearly about 5-6 years ago, after about 20 years of construction, okay. They wanted to start on the cabling project, but it was halted because the cost has ballooned to, I think, about 40-50 billion ringgit or something like that, something ridiculous, and at the same time there's some security issues lah. Because if you have to build the undersea electric cable, you will have to cross through Indonesian waters as well, okay? Because they've got the Natuna Islands right in the middle of South China Sea, in between Peninsular Malaysia and also Sarawak. Therefore, the government said no lah, we're not going to do that. So now most of the electricity, all the electricity being produced by Bakun is being used in Sarawak alone. So Sarawak has got this huge amount of energy reserve lah, okay, because they also have got coal power plants. There's a lot of energy, too much. Okay, so now Sarawak government has to go into industrialization in order to use up all the electricity reserves. Otherwise, we'll go to waste. Okay, so there's an opportunity for Sarawak right now to really, really develop themselves. Okay, but they have to catch up lah. They have to open up land and whatnot. Yeah. And start industrializing themselves. Okay. Having said that, you will be producing more electricity, you will be, emitting more carbon or whatever lah. But having said that, most of their electricity is coming from Bakun. So electricity generation using hydroelectric is almost zero emission. almost zero carbon emission. Okay, so we use up electricity almost exclusively from water lah. Okay, yeah lah. There's a lot of ethical issues when it comes to building dams, kan, you know. The biggest problem that the country faced when we were building Bakun Dam, this is well before you were born lah. Okay, was the displacement of local communities, and most notably the Penan people. Okay, the Penan people at that time, they were nomads. They're still nomads right now. Okay, so on most of their lands, the locations where they were roaming about, you know, at that time, had to be given up for the dam. Okay, and then these Penan people didn't have proper settlements. They don't have any proper settlements. They're nomads. So they go around to a certain location, they started building huts and whatnot, and then after all the resources over there are used up, they go to another location, another. Therefore, can you know, it was really difficult for compensation. It was really difficult in terms of, you know, ethics, like, you know, whether or not to build proper settlements for them to settle in, whether or not they will use a settlement like any other people. So there were lots of issues. And then this issue became international issue, and people all over the world were condemning us, you know, saying that, you know, we are doing a lot of injustice to Penan lah, to what, you know, just like the orang hutan lah. So a lot of bad press then lah. But nevertheless, you know, things have quieted down. Now, if you go to Sarawak, the displaced Penan people are already occupying other locations in deep within Sarawak. They're being looked after. So there's some good things that has happened lah, right? But nevertheless, you know, they're opening up a huge dam such as Bakun was not a good idea lah, not an easy thing to do sebenarnya. And then, you know, you had to level up, you know, take away all the timber and whatnot, then, you know, clear out the forests. So you lose forest and then you put into place water. So technically you'll be losing the ability to absorb carbon, you know, because there's no more trees, and you're losing the ability to produce oxygen as well because there are no more trees, right? And at the same time, Sungai Rajang and, you know, the major rivers within Sarawak also will have reduced amount of water flowing through them because of the big dam. The good thing is you will not get flash floods anymore in Sarawak. Okay, previously there were lots and lots of flooding everywhere. But because of the Bakun Dam, that has reduced considerably. Having said that, a lot of these rivers, if you go way up into the deep end, sometimes in the dry season, there's just too little amount of water that boats cannot go through anymore. So that's a negative lah. Because you know lah, in Sarawak, the river is the main transportation route. Yes, they're building a Pen Borneo highway, but it's only going a certain direction, kan, you know. The river, it goes the other way. So, you know, they lose out in terms of transportation certain parts of the year. They lose out in terms of, you know, perhaps certain amount of fish within the river as well. They lose out in terms of, you know, resettlement of people and whatnot, but they gain in terms of electricity, they gain in terms of, you know, economic gains and whatnot, and so many other things. So balancing out, not very easy. Here on the peninsula, you know, the latest hydroelectric dam that we have is actually Kenyir. And Kenyir was built a long time ago, you know, way back in the 1990s. The largest freshwater lake on Peninsula Malaysia, and it's artificial. Okay, produces a lot of electricity, of course, but still in total, for the whole country lah, you know, only about 20% of the whole energy generation that we have. Still quite low. Okay? And then increasing that will be challenging because you need to create huge dams. Only Sabah doesn't have a really big one. But at the same time, perhaps, you know, Sabah might not be able to get a hydroelectric dam anyways, you know, because of the topography and whatnot, you know. Therefore, they have to look into other means. So the other one is natural gas, of course, and we're burning our own natural gas, you know, produced locally, taken out from the ground within the South China Sea, and being burnt for electricity, our own gas. Okay? It's a good and a bad thing lah. You know, at least it's coming in. We are burning our own gas, you know, so we don't have to import it. Less amount of carbon emission. But having said that, it's still hydrocarbon. So looking for alternatives will be better. Oil, okay. So You either burn petroleum, or you burn natural gas, or you burn coal. And then at the same time, we burn diesel. So many different mixes. Okay. And this is because we don't just have TNB, SESB, and Sarawak coal. You know, we also have many independent power producers, the IPPs, such as YTL and a few others, EDRA or whatever lah. So these companies are burning many different kinds of resources in order to produce electricity based on economics, based on technology that they get, that they have, right? So it's quite a diverse mix. And the last one is renewable energy resources. Okay, so renewable energy sources, for instance, biomass. Biomass is a product of, let's say, agriculture. So from the palm oil estates, they will be cutting down trees, pruning their trees, you know, the fronds of the palm trees, and then, you know, the fruit bunches and whatnot. You know, when it gets pressed, all the fibers are being thrown away. Okay, so these fibers, the cuttings from the trees themselves, the tree trunks and barks and whatnot, even from rubber trees, from many different kinds of agricultural waste as well, like, you know, paddy husks, the stalks and whatnot. And then you get a lot of biomass from animals as well. Again, you know, from cattle farming, from pig farming, from all these things. If you put all of that together, a lot of energy can be produced, even from rubbish. Okay, so we can burn rubbish in order to get energy. So in some countries, they incinerate, they burn the rubbish. Let's say like Singapore. Singapore incinerates the rubbish, burns the rubbish for energy, and then the ash from the burnt rubbish and the burnt biomass is being used as material to go and create new artificial islands. That's what they've been doing. That's how they've been expanding their island. And, you know, now they have a number of smaller islands to the south of Singapore, which are being made out of artificially, using rubbish, using ash from rubbish being burnt, from biomass being burnt. Even in Thailand, they're using a lot of biomass from the agriculture to produce electricity. The technology is already available. It's very close by to us. And it's not that expensive anymore. Somehow or other, very, very few companies in Malaysia are taking it up. I only know like there are about 3 companies in Malaysia which are doing it, you know. And then they're complaining that it's expensive, it doesn't really make you a lot of money, and so on and so forth. Like, you know, perhaps the issue is just because of supply and demand. Okay, demand will always be high. At the end of the day, the products they produce electricity, and TNB will always pay them. Okay, but the supply side, the raw materials coming in from all over the country, you know, to only a couple, 2 or 3 locations throughout Malaysia, you know, will require a lot of transportation, of course, you know. So therefore, the volume too, although is available, but it's not very easy to move all of that biomass to only a few locations. It requires a lot of investment, okay. So perhaps, you know, if we can look more into, you know, making it a reality, by introducing enough transportation or whatever, to that would definitely see an increase in the amount of energy being produced through burning of biomass, and perhaps in the future burning of rubbish. We also have some incinerators producing electricity, but very small ones. For instance, like, you know, if you go to our technology park near Astro there in Kuala Lumpur, I think there's another one in Kulim High Tech Park. You know, there are only a couple of places in Malaysia where we have rubbish incinerators that produces electricity. Rubbish to electricity incinerators, okay. These are highly specialized plants, okay, and then they require a certain amount of rubbish every single day to produce enough electricity. Otherwise, you know, contractually, they won't be able to fulfill the demand set by the MD, of course, and they will have to pay a steep price for that. But nevertheless, you know, it's something that we have to look into because, you know, let's face it, our rubbish dumps. We have a number of rubbish dumps all over the country, and then if you look, focus on Peninsular Malaysia, out of I think nearly 200 rubbish dumps in Malaysia. More than half of that, about 70% of them are already over capacity. And then, a number of them have to be closed down because it's just too full already. You can't do much anymore. It's just too high and too full and you can't do anything else. So more will have to be opened up. So why do we have to go and open up more locations for dumping our rubbish? Why don't we recycle? Why don't we burn the rubbish instead and produce electricity? Wouldn't that be more useful, isn't it? So somebody will have to come in and invest some money and build all these incinerators and produce electricity for the better of everybody. You can go and dig up all those old rubbish and then take up harvest the butane gases from that for electricity. At the same time, use the rubbish and burn them and turn them into ash or whatnot to get electricity. So yeah, we have to move on towards a different direction, I would think. So there were a couple of studies which were done quite a while ago, okay? And then since then there have been very, very few community-wide kind of studies looking into how people use electricity. So the couple of studies here were done by CETDEM, the Center of Energy Technology Development in Malaysia, okay, located somewhere here in PJ. They studied a number of houses okay, within a couple of communities, and then they found out that total consumption per capita per capita means to say per head if you live in a bungalow it's so much higher than in comparison to to people living in single story terrace houses. So per capita means per head doesn't mean total, okay? So the total consumption if you look at it, it's still quite high in comparison to the terrace houses. For the terrace houses, it's about the same as semi-detached houses. But having said that, the per capita electricity usage for semi-detached houses are slightly lower than single-story terraces, and it's coincidentally the lowest one. Which is a bit strange because if you look at it logically, okay, terrace houses normally will only have two external walls, one facing the front, the other one is at the back of the house. And then these two faces, these two facades have windows and openings and doors and whatnot, those are the only two facades. And then they also have got a couple of shared walls, okay? So you don't get daylight illumination onto the walls, so you don't get heat coming in from there. And then coincidentally, you don't also get any heat at all coming in from the other house, whereas for semi-detached houses, at least you will have 3 facades facing outside, isn't it? With walls and windows and doors which are exposed to the sun. Somehow or other, that from this particular study, they found out that the per capita usage for semi-detached is still lower than terrace houses, but nevertheless it's about the same, okay. But for double-story terrace houses, it goes a bit higher. So it means that the bigger the house, the higher the amount of electricity usage per capita per person, right? So bungalows well above everybody else, okay? So so for you who live in bungalows, okay, you need to look into how you can save energy, okay? If you can do that, it would be great. At least those people who are living in semi-detached or single-story terrace houses and whatnot, they know for sure their usage is a lot lower always, because usually the houses are smaller. Okay, but there is an exception though. This is not widespread because it was only done on one community. If it's done on the whole country, let's say, it'll be a different number altogether. You know why? Because bungalows, if you look carefully around the country, there are also a lot of bungalows which are quite small. Okay, so there are a lot of bungalows which are really big, but there are also a lot of bungalows which are quite small. You go to rural areas, pretty much every building are bungalows, but they won't be using as much amount of energy that we use here in the urban centers. So there's a big difference there, right? So the caution is right now, yes, we have numbers here, but this is not widespread. You can't really generalize it to the whole population, okay? But it's an indication nevertheless. And if you look carefully, can the refrigerator there and cooling takes a cake. The biggest chunk of electricity that was expended was actually because of cooling, okay, because of cooling and refrigeration. Whereas everything else, not so much, right? The lighting, yeah, big chunk of it, but nevertheless, it's not as much as cooling, not as much as refrigerator. Okay, so the answers are here already. So for us, at least as an indication lah, when we design something, you design the building and make sure that it's cool enough on the inside, insulated, good amount of ventilation, and then at the same time, you provide active systems, aircon or ceiling fan, whatever which are energy efficient. That would surely limit the amount of electricity consumption. Okay. And then there was another study by the same people, okay, but a different community. Okay. They also found out that the total consumption per capita, look at this one here, a different community. The bungalow is a lot lower now. 7 liters is a lot higher, so it depends on the community lah. So you can't really generalize it throughout the whole country, so to speak. You have to look at it from one location to another location. It all boils down to behavior, okay, and also the availability of certain technologies within the building, okay. But something cropped up quite consistently. At least for sure that cooling plus refrigeration will make up more than 50% of the amount of energy, electricity that you use. This is throughout all of this. Okay, so that's quite consistent. I mean to say, at least we can pinpoint that cooling and refrigeration are the two biggest culprits, right? Heating here is, dryers and whatnot can still quite high, but nevertheless, these two are the highest ones. We can concentrate on these, and then pretty much, for architects, we can concentrate a lot on cooling. We can also concentrate a lot on lighting as well. The two things that we can really make an effect. Okay, so we can look into the lighting, we can look into sizing of windows, location of windows, shading them. We can look into the specification of our walls, in terms of the insulation in the walls, in terms of the thickness of the walls, the materiality of the walls, the U value of the walls. If you remember your U value and your R values, and then perhaps look into shading the walls or shading the windows, and then also look into the specification of your roof, how thick is your roof, the materiality of your roof. Do you have insulation in it? Do you have ventilation in it? So all these things are connected together in order to allow for optimum daylighting and optimum cooling. Okay. So to make it even better or more comfortable, if you need air conditioning, then you provide active systems which are efficient. Okay. So again, you look at this: 50% for cooling, the other community, okay, and about 12% for refrigeration. So still the biggest culprit lah. So this is a hypothetical kind of graph lah, okay, to show the amount of electricity that you probably use per day lah, right? So and then the difference between the three kinds of people, okay. So you got city center dwellings, you get suburban dwellings, and also rural dwellings. Consistently, in the afternoon, the amount of electricity will drop considerably. This is perhaps because you go out, you work, you're outside of the house, okay? And then once you get back to the house, it will increase. It will start to increase bit by bit. And either it's earlier or later. Because the city center dwelling a bit later lah, because you're stuck in traffic jam and whatnot, If you're in the suburban, rural area, the faster, it becomes faster lah that you come back home and start using electricity, and it goes up to a certain amount, right? In suburban areas, the houses are bigger, There's more air conditioning, there's more equipment at home. You use more electricity. Okay? So hypothetically, this is the trend, like, pattern, difference between the three kinds of dwellings, like, according to locations. Out of all of the calculations which are really important, is this one. And it's also emphasized in GBI as well, BEI, or building energy intensity. Very easy to calculate, all you need is just two different kinds of information. One is the total energy consumption per year or per month or per day, it doesn't matter. And then you divide it up with the GFA, the gross floor area. My preference, usually I would divide it up with the whole thing, GFA, total, including the internal car park and everything else, okay? But some other people, they might calculate the BI without the GFA. So no, not GFA, they calculate with the net flow area. So without the circulation area, without the toilets, without the car park and whatnot, but to me it's a bit awkward. Because, even in the corridors, you still use up electricity to illuminate it. In the toilet, you still use up electricity to ventilate it, to illuminate it, right? Same goes with the car park as well. So why not include everything in? Therefore, it's better to do the BI by dividing the total energy consumption by the GFA, okay? And then based on what information you have, either per day, per week, per month, or per year, you multiply to get a per year number, okay? So at the end of the day, you get a certain number lah. So that number will show how much the intensity of energy usage within that building. Okay, the higher the number, the worse it is. So there are three examples here. A two-story bungalow is about this much, quite low, but it is a bungalow, of course. You compare this to a bigger building, then it'll be, you get to see that the bigger building uses up a lot more energy, of course. The total amount of energy, this is based on residential college, this one, residential college in UM. And then we divided it up by the size of the buildings, okay? And this is what we get. Quite efficient, which is not bad. But yeah, it's quite evident because there are not many aircon around, a lot of ceiling fans. Therefore, it's lower than a faculty building, okay? So there are three ways of the three solutions when it comes to energy efficiency. Okay, you've got no-cost measures, you've got low-cost measures, and also high-cost measures. We as a consumer, as a people who wants to invest in energy efficiency, we choose whichever we want to use. But to me, you can go for the low-hanging fruits. The easiest one. The easiest one will always be no-cost measures and low-cost measures. With those alone, you should be able to see a marked reduction in electricity consumption. And then, by replacing some really big or some really big and expensive equipment such as aircon and a few other things, you should be able to see even more cost savings, energy savings, okay? But that requires more capital investment, okay? So in terms of examples for no-cost measures, okay, just change your aircon setting. Change it to 24 or higher than that, according to your comfort. Don't run it at 22 or don't run it at 20 degrees or 18 degrees. Can run it at 24 or more than that. Okay. Set your refrigerator to 18 degrees if you can, or even higher. Turn off lights, the appliances when not in use. Okay. Even your Astro decoder pun, if you can, you switch it off straight away lah, can. Lately, a lot of houses will probably have unify their houses. It's almost like a requirement nowadays. It's a necessity. It's no longer a luxury. So that one, if you can't afford to switch it off, then just leave it alone, okay? But nevertheless, leave that one alone, leave the refrigerator alone, but everything else, if you can switch off can. And then perhaps just leave one or two lights on at night when you sleep, besides your aircon and your ceiling fan. So try to be as frugal as you can, if I can put it that way, okay? You have to actively manage your indoor temperature. Open up windows, open the doors, ventilate your house, remove the stale air, whatnot, again. And then, if it's cool enough, especially in the mornings, open up the windows, let the cool air come in. Even at night sekalipun kan. But make sure that you have mosquito nettings lah, because lately ni dengue is such a menace kan. People are really afraid of COVID-19, including me. Okay, but having said that, if you look at dengue cases in Malaysia, we have about 30,000 cases of COVID-19 now. But dengue, we've got more than 80,000 cases now this year alone. In terms of death, COVID-19, we have gone past 250 already. They're around 250 deaths kan. But for dengue cases, a bit more double than that, you know. There's a lot more dengue fatalities because of the mosquito in Malaysia in comparison to COVID-19, you see. And dengue has been here for a long time. There's no cure for it, you know. Once you get dengue, that's it, kan, you know. You either die or if you don't die anyways, can you suffer a lot lah, you know. I had the privilege of being infected by mosquitoes and I got dengue before. It was really bad, very difficult, you know. You can't even drink, you can't even eat, you can't even sleep, you can't even sit down, whatever lah, you know. It was pure suffering for 2 weeks. So look after yourself lah, you know. When you open up your windows, make sure that you have mosquito netting lah, you know, or kill off mosquito if you can lah. But you know, the point is actively manage your indoor temperature. Okay, and then when you wash your clothes in your washing machine, you don't have to use hot water. Somehow or other, people use hot water. Why? You know, there's no point. It doesn't really make any difference if you wash your clothes with cold water or hot water. If you say that it will damage your clothes, can you know, try and wash it with cold water after a number of washes. I don't think that you see any damage at all to your clothes. Doesn't really make any difference, you know. Perhaps you get more bubbles, you know. But having said that, just wash it with normal water, okay, that comes from your tap. And then if you can, don't use dryers, okay. If you're living in apartments, sometimes it's a necessity that you have to use dryers. Okay, why not use it, okay? Otherwise your clothes will not get dry again. Otherwise, if you live on the ground in bungalows, semi-detached, whatever, can, you know, just go outside and put it onto the clothesline. Why not? You don't need so much amount of heat to dry your clothes. You just need a little bit of air moving around it. So if you just leave it outside to be exposed to the wind, to the air and also the sun, okay, for 2-3 hours, it will dry. Otherwise, we as architects, we can design a proper way for people to dry their clothes. If you notice, you know, in the design of houses, sometimes we have courtyards, sometimes we have like a terrace at the back of the house, shaded terrace. So you know, this shaded terrace is actually a place where you can hang your clothes to dry. If you make it a bit more private, with breeze blocks, let's say, you know, to allow breeze to come in, and also the roof is slightly open, then you know you can hang your clothes in there privately, you know, so you don't show off you know, your private clothing or whatnot to the public, and at the same time you can dry it off. So something that the architects can work on, right? So if you can provide that space in your houses, then it'll be very good, and then, you know, use stairs instead of elevators. If you live in the 17th floor, definitely use the elevator. It's ridiculous to go and walk up 17 floors, right? But if you live on, you know, second floor of your building, just use the stairs. You know, and the faculty, you know, if you can walk up 2 or 3 floors, by all means, you know, why not? It'll be good for you, you know, in terms of health and your well-being, but at the same time, you know, it saves energy as well, So if you're a building owner or building manager, it'll be good for you to do some campaigns, promotions, put posters, use a staircase rather than an elevator, let's say. Low-cost measures, quite a number of these. There's so many others as well. So you can replace your light bulbs, okay, from fluorescent bulbs to and incandescent lights to LEDs. And then install ceiling fans to circulate the air. If you don't install your ceiling fans or your fans, you don't circulate the air, you will not get thermal comfort anyways. So it's better to have the fans. Insulate not just the walls and whatnot, but also insulate your hot water system. Nowadays, many houses have either a centralized hot water system, or an instant hot water system, or a solar hot water system. Okay, there are three kinds of hot water systems here. But the point is, the pipes are usually not insulated, uninsulated. You only have plastic pipes. So plastic pipes will lose the energy, okay? So all that heat goes to waste. So it's much better to use insulated pipes. By doing so, you're keeping all the heat inside it. Therefore, you're not wasting the heat. For the instant hot water too, different matter lah, because from the instant hot water heater though, there's only one hose to the shower head kan. So that's an exception lah. But for the central heating system, central boiler system, which provides hot water to 2 or 3 toilets kan, it is best to make sure that all the pipes are insulated. Otherwise, you'll be wasting a lot of energy because you use a lot of energy to boil out the water, but you lose that heat very, very easily. So wastage. Okay. And then the solar hot water pun is best to make sure that all the pipes are insulated as well. Otherwise, even though you get energy from the sun, but you're wasting it nevertheless. And then next one is to replace the air conditioner filters regularly. Either you replace it or you clean it. Just take a chair, go up and open up the front of your air conditioning unit, the diffuser though. Open it up, take out the dirty filters, wash it, dry it up, and then put it back in. Take your vacuum cleaner, vacuum your aircon. Make sure your air conditioning system is clean. Okay? You don't really have to call in the technicians to come in and clean it out for you. You can do that at least perhaps once every 2 years or so. It doesn't have to be so regular. Okay. Let's say if you need to top up your gas, you probably call somebody in and get that person to clean it up, clean out the diffuser and also clean out the compressor outside your building. So both will have to be washed and cleaned properly. Okay. If it's dirty, your aircon will use up more electricity to cool down the space, right? And then at the same time, it might not be really healthy for you as well, because you might be breathing in air which has not been filtered properly. Okay? So there's a lot of dust in it. So sometimes it's good to not just clean your aircon, but in terms of health and well-being, perhaps you look into air filters. And then if you can replace the refrigerator and freezer seals, will be good as well, especially for those freezer and fridges which are old. Old freezers and fridges you probably notice that the doors might not stick as much anymore. It might not be very hard to open it because the magnet is losing its strength. So you will get some coolness seeping out, leaking out of your fridge. So it's best if you can sort of replace those the seals tight. If you can install dimmers or motion sensors for your artificial lights, by all means, go ahead. Be good. Sometimes you even have occupancy sensors. So even for aircon, there's some air conditioning system which has got sensors. Econavi, they say, it will detect the amount of people within the room and increase or decrease the output of the aircon accordingly. But you have to spend more in order to get such a unit in your house, isn't it? But nevertheless, you will really look after your energy efficiency. And then another low-cost measure is to fix the building air tightness. I mentioned this earlier a few times. What you need to do is simply just make sure that your doors and windows are tightly sealed. Okay, so if your windows are ajar, you lose out all the cool air, so you're wasting your money. If your doors are not closed, also have got a big gap underneath it, try to let's say put a towel there, or perhaps buy those plastic strips. A number of years back, one strip will probably cost you about 30 to 40 ringgit. Nowadays, you can buy a strip for only 8 ringgit, from Aeon Big or other different kind of stores as well. And then you can fix it very easily as well. It only uses double-sided tape, or if it doesn't really stick, use nails, or perhaps super glue, just to put things into place. But that will definitely increase the efficiency of aircon by quite a measure as well. Try it, it's very cheap. And then the high cost measure. You have to go into auditing your energy efficiency, energy usage. You hire a qualified auditor to look into it and tell you exactly what to do. Okay? So expensive, but good for commercial entities, for industrial entities, especially those, because the bottom line for them is profit at the end of the day. So investing some money into this will take them a long way. And then perhaps replacing the old appliances, old refrigerator, old TV, old everything, replace lah, chuck them out, go and recycle them or send them out. Then buy something new with 5-star rating. And then replace lighting to high efficiency lights. Use LEDs, UT5s and whatnot. Okay. But nowadays LEDs and T5s are cheap, so you can't really say it's a high cost measure anymore. It's becoming a medium cost or low cost measure now. Replace the old air conditioning units with high efficiency ones. It can get a bit expensive, especially if you have a lot of aircon units in your house or at your office. And then those buildings which has got central air conditioning system, replacing the old central aircon is really, really challenging. It takes a lot of effort, a lot of capital investment, a lot of time as well. So when you start to replace the old aircon with a new aircon, you probably have to close down your office for at least a week in order to do so. So might be a good thing, might not be a good thing. It depends on how you look at it. But nevertheless, an old aircon, central aircon system might not be good for your health actually. If you have not been looking after the ducting, especially, there might be a lot of pathogens in there, a lot of dust, a lot of really dirty bits in there as well. So you're breathing really bad air technically, right? So you might get some animal droppings in it as well. So if you can, flush out the system regularly. After a few years, you flush it out again. Because usually flushing of aircon system only happens once, just before the building gets open during the building commissioning period, just before handing over to the client. And after that, no more flushing. Why not? You're supposed to be flushing it, but most of the time people don't flush the aircon ducts. To them, it's just a nuisance, extra work, to clean up something. And then at the same time, usually building owners, they don't wash or clean up their cooling towers. They don't go and clean up their aircon plants. They don't go and clean up the aircon water tank. All these equipment have to be cleaned up and maintained regularly, to maintain not just the efficiency of the system, but also the health and well-being of the occupants. But the reason why SARS, the severe acute respiratory syndrome happening, spread like wildfire in Hong Kong a long time ago. It was because of aircon, because of cooling tower. The cooling towers in Hong Kong were dirty, really, really dirty. So, and that has spread the disease even quicker. Okay, so replacing all aircon I think is something really, really urgent, very important. If your aircon system is more than 20 years old, it's high time to consider replacing it. Otherwise, it might not be efficient anymore. Secondly, it will probably not promote good health anyways. Throw them out, replace them with new ones. And then installing warnings, tinted window films, putting some green cover over your roof of your building, have some green facades, green roofs. This is all to reduce the heat gain, okay, as well as installing insulation in the walls, in the roofs, okay. So insulate the existing roofs and install some reflective film, okay, on your glass, or perhaps can install some reflective paint on your roof. So paint your building. Don't just leave it bare. I know some of you might like the brutalist kind of architectural language. I like it too. But having said that, can you know the brutalist architectural language too? And there's the biggest drawback is that the gray color of your walls will absorb too much heat, right? And then the concrete that you use in your building will also absorb too much heat and let it out at night, so it might not be very comfortable. Whereas if you go local, you go some contextualized kind of architecture, you timber, let's say, or something very light, large overhanging roofs, you limit the amount of heat gain. You limit the amount of solar radiation, right? So you choose the kind of architecture language you want to use, okay? If you can, try to contextualize it, but nevertheless, painting will help. Painting will definitely help. If you paint your building with black, it doesn't help as well. Increasingly over the past 2-3 years, you're seeing a number of buildings being painted black. To me, it's not cool, okay? Black cars are cool, black motorbikes are cool, okay? Black phones are cool, but black buildings are not cool. Literally not cool. Because it will absorb far too much amount of heat. And then the buildings are built using sandstone, sand bricks, and also cement and whatnot, concrete. It will absorb even more heat, and all that heat will be dissipated inside the building throughout the rest of the day. Beyond 4 o'clock in the evening till late at night, you can feel the heat being emitted into the house. So these apartments, you would definitely need aircon, a lot of aircon, big horsepower aircon. Otherwise, you will stay warm inside the house. To me, it's just a really daft, kind of decision, painting a building black. You can do that perhaps in the in the Arctic region, but not here in a tropical region where it's really, really hot and the sun is always on top of our head. But yet again, you see not one but many buildings being painted black. The latest one here in Pantai Dalam, in Bond Estate, it's being touted as a very expensive, high class kind of condominium. But the reality is, when you paint the building black, the owners or the occupants of the building will have to pay a lot of money cooling down the units, which I think is counterproductive. Then I think go back a year, you probably see the Alila Hotel and residences in Bangsa. Huge building, 50 stories, totally black. There's no shading whatsoever from surrounding buildings because it's the only tall building there. So definitely there'll be a lot of solar radiation onto it, and you need a lot of air conditioning to cool down the building. Okay, and then you go to let's say Sungai Way there, there's a whole city, so to speak, a number of buildings being built by the beside the Federal Highway there. And they're all totally black. Why? I don't quite get that. It's nice to look at black cars. I really love black cars, but black buildings, not cool, literally. So I think don't do that. We as architects, I think we have to think better than what other people have done, right? And then replace existing glazing if you can. Use low emissivity glass, low E glass, or put some films on the glass to reflect the heat. Otherwise, you go for double glazing or triple glazing if you can. If you can afford it, then go ahead for double glazing. For at least for double glazing and triple glazing, there's a second benefit, which is acoustics. Not just for stopping the heat from coming in, but at least acoustically it becomes a better building. Especially if your building is sitting right in the middle of the city, where the traffic is really noisy. then go for double glazing. Just a small price to pay lah. And then, the other one is to insulate your east and west facing walls. These are the two walls which are facing the sun in the morning and the afternoon. So especially the western side, best to insulate it. And then, or perhaps use a different material. When you're designing a new building, use materials which has got a high U value. With good U value, okay, that limits the amount of heat transmission into the building. When you look at glass and the U value of glass in comparison to, say, an AAC block, an autoclave concrete block, in comparison to, let's say, a clay bricks or even cement bricks, or timber, let's say, the U value differs widely. Okay, and then basically it shows how much amount of heat that can be transferred through the material. So timber will probably have one of the best because it doesn't really absorb a lot of heat anyways. But having said that, something contemporary close to bricks is AAC. Previously you had to import the stuff, but nowadays it's locally produced in Negeri Sembilan. And a lot more buildings are using AAC nowadays, and it's good because you just need to saw the blocks into place. Normally you have a bigger block, you don't have smaller block, bigger blocks. It's saving time and also effort on the labor side to lay down the walls. But at the same time, you don't use a lot of cement as well. You use a certain kind of adhesive that limits the amount of cement. So that limits the amount of resources that you put into the building as well. So it's a benefit. And at the same time, because a bit more accurate. So your corners, your window sills and whatnot, you can cut the blocks into shape. So you don't have wastages like what you probably have previously. Okay. So previously you were probably as a building contractor if you had to build a wall, and you will probably be ordering a whole truckload of bricks, and then they come into the site, the truck, rather than in pallets. Okay, AAC comes in pallets, very finite amount of blocks in a pallet. Red bricks, they come in lorries, in trucks, and then they get dumped onto the ground. Okay? And then usually easily between 10 to 20% of the bricks get broken. Not good in terms of quality, building quality at the end of the day, the quality of work, the workmanship. Not as good as AAC, because AAC is nice and clean and smooth. Whereas for clay bricks, you have to apply the rendering as best as you can in order to get nice smooth finish. But having said that, if your wall is exposed, there's no rendering whatsoever. You get to see the bricks there. And if the bricks are not in good condition, they were broken up and whatnot, there's a lot of wastages, so you have to buy more. So not necessarily you get savings by using cheaper materials such as clay bricks. Okay, so why not use AAC instead? And then another one is to install exhaust fans. This is to allow air to move out of your building. Okay? Kick out all the stale air from the building, so that your aircon doesn't have to work so hard, and at the same time you will be breathing in really good, clean air. Okay? It's better for your health and well-being. So what about assessing your energy as consumption? The auditing bit. First and foremost, you need to do a baseline. From earlier, I showed you the BEI. For many kinds of buildings, there's a baseline to it. Okay? For offices, it should be ranging between 200 to 400 kilowatt hour per meter square per year. For houses, there will be a different number and so on and so forth. Okay, and then you need to look at the data collection methods. You have to identify the type of building, whether or not it's a school, it's a theater. A theater will probably use a lot of electricity because you have to use more air conditioning to cool down a really large space. The theaters can. So even in a university kind of setting, certain buildings will use more aircon than another building. So a building which has got a lot of lecture halls will use a lot of aircon. We use out a lot more electricity. The library will use out a lot more electricity in comparison to, let's say, offices or labs. So you need to identify these buildings, and then estimate the occupied floor area, estimate the workly operating hours, find out the number of computers, number of big electronic items. Okay, so you have to do some profiling of all the equipment that you probably have in the building. The equipment can be computers, can be large freezers and fridges, can be so many other things as well. Like, research equipment, machines, whatnot. If you go into industrial installations, there might be some machines to manufacture something. And then look into the occupants, look into the monthly energy bills as well. So in the context of doing your assignment later on, you need to get the energy bill, of course. We don't have a bill, but we do have the reading. So we're compiling the information, and you just need to analyze it. Okay, come up with some statistics, whatever. Okay. So for water, unfortunately, because JPPHB has not been recording it, so you need to come over to the faculty and go to the water rack, take a picture on a certain date, and then one whole month later come back again and take another picture, and then try to analyze how much amount of water that has been used over that period of time. Okay, so you probably need to do that for 3 months, 2 months at least. So therefore, the water gang, the group which has been tasked to do water efficiency for your assignment, you are the first guys to have to come in and take the reading straight away. Might not be accurate because at the end of the day, there's very small amount of people in the faculty. But having said that, still need to record it. And then in terms of baselines, this is coming from Common Carbon Metric book, published a long time ago, 2010. But nevertheless, it's based on pure research done locally in Malaysia. And then for offices, the energy intensity is sitting around 200. Okay. Around 200 kilowatt hours per meter square per year. And this is based on 0.66 kilogram of CO2 per kilowatt hour being produced. This number has not changed much. And this is the national average. If you go to Sarawak, it's a lot lower. If you go to Sabah, it's a lot higher because of the energy mix that I was talking about earlier on. Okay. Sarawak lower because of Kembakun Dam, of course. There's less amount of carbon emission. Sabah, there's a lot more coal power plants, so the number is a lot higher. Over here on the peninsula, we have a good mix between hydroelectric and biomass plus other things as well. Therefore, the number is at around this figure here, and then this is the median, the average. Okay, so by multiplying, you get the amount of carbon emission intensity lah. So the amount of kilogram of CO2 equivalent per meter square per year. So every meter square of your building per year, this is the amount of carbon that kilograms of carbon that you emit. All right. So the bigger your building is, the more carbon emission you will be emitting. Similarly here, the amount of kilowatt hours, the amount of electricity that you probably use per meter square of your office building per year. You look at a hospital, double. Almost double. Hotel, even more so. Schools, very low. Because a lot of our schools are, running on ceiling fans and a lot of openings. And not very comfortable. Unless you go to private schools, of course, Bungalows, even higher than schools. 70s, about the same size, same as the schools. Double-story terraces, very low. Apartment condominiums, low as well. Affordable homes, somehow rather quite high. Comparison semi-detached. Why? This is the number which has been produced nationally, used nationally. So somehow rather the multi-story flats, the DBKF flats, people living there are using a lot more energy, 3 times more energy than those people living in single in double-story houses, double-story terraces. So collectively it's more, right? So from this you get to see that the hotel is perhaps the worst kind of building in terms of energy intensity. Perhaps it's because of behavior as well, because people go to hotels, they want to indulge themselves, I do the same thing as well. If I go to the hotel, I probably want to use everything, isn't it? Some people go in and start filling up the tub with warm water, hot water to dive in there and, you know, bask in it. And at the same time, switch on the TV, switch on the aircon, switch on everything, and leave everything on all the time. Because you want to indulge, right? So perhaps that has contributed to the large, to the high intensity in terms of energy usage in hotels. Hospitals, you can't run away from it. You have to switch it on all the time, right? You know, the lights will have to be on all the time. The aircon will have to be on all the time. And then you have to air condition pretty much everywhere in the hospital, even the corridors. But, you know, you have to look into efficiency lah. But sadly, if you go to, let's say, PPUM, our own hospital pun kan, a lot of corridors which are air conditioned, you know, some of them have got windows, okay, and some of them have got some louvers and whatnot, okay, air conditioned but louvers, so you're losing all the coolness. Not very efficient, isn't it? And then there's not enough amount of air curtains, you know, to limit the movement of cold air, and you need air curtains to stop it. If you can't put windows or doors to segregate the spaces, then yes, just use air curtains. Can be a bit noisy though, you know, but at least it stops the aircon from running out. Yeah lah, you know, there's a lot of efficiency measures that need to be done lah. But having said that, you know, besides PPUM, you go and look at all the other hospitals, they all will be running on a lot of electricity, a lot of equipment, a lot of you know, appliances here and there. A lot of air conditioning in comparison to ceiling fans. Some of the wards will probably be using ceiling fans, but these are older wards, older hospitals. A lot of the newer hospitals are all air conditioned. A lot of them are air conditioned, you know, almost entirely. There's a good and bad thing, okay, but nevertheless, that's what it is. That's the reality. So very high amount of intensity of energy usage in hospitals. What is missing here is actually airports. Okay, airports also use up a lot of electricity because of large volume of spaces that need to be air conditioned. Similarly, you have got rail terminals and things like that. Okay, but airports, we do have a number of airports, not as much as hospitals, but they realize they also eat up a lot of energy lah. Okay, so this baseline here is the baseline of fundamentals. Okay, you can base on this. And then go into the kind of the type of data collection method. Okay, you can measure, you can calculate, you can also do some load balances. Okay, in your context, you know, for architects, I think it's easier just to measure or to calculate lah. In our case, because we already have the not the bills lah, but monthly usage recordings, we can calculate differences between one month and another month, okay? And also you can also calculate the BEIs, of course. But in some instances, you know, you might have to measure. In your case, you don't have to, you know, but to measure, I also have got some meters, but you don't need to, you know, you don't have to. And at the same time, you have to sort of get the help of qualified technicians to come in and really fit the equipment to place, okay? So a useful one for now, which I might get you to do, especially the energy efficiency group is to go and plug my meters to the central aircon system that we have at the faculty. But we'll see how it goes, okay? Because I need to make sure that the equipment is safe, it's sitting in a safe location, at the same time it's not exposed to the weather. Otherwise, you know, if it gets wet, then, you know, 30,000 ringgit worth of equipment will be totally defunct, you know. So we'll see how it goes. But nevertheless, we have the whole building for electricity. And then, yeah, it's the best way by measuring. At least you get the actual, right? And then the recommended data collection methods is usually desktop to field. Okay, field means to say you go and measure something. Desktop means to say you got information from somewhere else. So for desktop data collection, you can collect preliminary building energy related data, you know, or number of people, whatever, you know, then all of this information. Energy bill, historical data, if you can get 12 monthly, I think this one we have it available. Drawings, we have it. air conditioning system, we've already asked from JPPHB. So, myself, Sally, and so on, we've already done all this for you, okay? So hopefully you can benefit out of it. Therefore, we're looking at, we probably, expect out of you some really good proposals again. Lighting drawings, I think something that you might have to do. It depends. Lighting ni is pretty much to estimate the amount of artificial lighting that we have, and also estimate the amount of energy that it uses, right? Because just now we can clamp onto air conditioning to find out the amount of electricity that it uses, but for lighting, artificial lights, it's not very easy because there's hundreds of those within one building. So you can't go and climb onto every one of them, so you probably need to climb onto one and then measure it for a certain amount of time and multiply lah. So to multiply, you need to know the numbers, of course, right? Then the other one is asset records, to find out how much amount of equipment there is, within the building, so that you can find out, how many amount of computers, printers, so on and so forth, okay? So you can go around the building and do an inventory on it, okay? But having said that, the faculty also has got this, right? And then the weekly operational hours, you probably know this one. Number of coupons, yes, we can estimate it, right? And then from field data collection, there are a number of things that you need in order to complete missing data, which you do not get from other means. And then it is also to verify the data. Okay, sometimes when you look at the drawings, it says that we're supposed to have, let's say 500 amount of artificial light fitting. Suddenly you found out on site there's only about 200 of them. So verifying, okay, and then understanding closely about the building operation, okay, to make observations and look into wastages if there are any, okay, and then carry out some necessary measurements, let's say to climb onto certain big equipment to find out how much more electricity it uses. So this can be done. I've got the equipment for it, okay. So if need be, we'll do that, okay. And then we just climb onto it and then leave it for about 2 months and see how it goes. And then there are a number of equipments that you might need to use in order to do some energy audits. You use anemometers to find out the air velocity. I don't think you need this so much, okay. Hygrometer, inside, outside air humidity. Usually these 3 and 4, they're all in one kind of equipment. So you can have a handheld one, or perhaps ones which are data loggers as well. So they can log the air speed and the humidity and also the temperature and also the light intensity all in one go, in one equipment, and you just leave it there for a certain amount of time. You can. Otherwise, you use a handheld ones, so you get a recording, a live recording at one particular time, and then record it manually, okay. And then the other one is the clamp on amp meter, which I have, and also the kilowatt hour data logger, which I also have, right? So if you need to use this, then we just use it. Otherwise, we just rely upon the whole building kind of energy consumption records. The flue gas analyzer, you don't have to do it now this time, okay? Because this one is pretty much for looking into particulate matter, looking into CO2, carbon monoxide, carbon dioxide, nitrogen, and whatever, okay? So not as important for us right now, because in GBI also this is not one of those things that you really need to look at, okay. Later on when you look through GBI punya the rating criteria, okay, the indicators, it will state many different kind of requirements that you have to satisfy, okay, and this might not be there. And then estimate the occupied floor area. You get the drawings, of course, soft copy, okay. So you should be able to sort of estimate the GFA for the building accurately, yeah. And then you can sort of also come up with the net flow area as well. Take out the car park area and then based on interviews and whatnot, you should be able to get the operating hours. And then obtain the plug loads, computers, and all the other equipment. And then for occupants as well, look into employees and staff, and the lecturers, plus visitors and also students, and 3 stakeholders here. Okay. And then the monthly energy bill, of course. Okay. So that's about it. With all this, you should be able to do the auditing, and you should be able to conduct your assignment really well as well. Okay, I've been talking too much already for the past 2 hours and 20 minutes. Okay, so any questions before we adjourn for today? Any questions? Anything not clear? If you notice, okay, if you open up the Spectrum page, it's already fully updated. So all of the relevant information are there. You can go online and download all the documentations if you want, or you can read up online. Okay, so there's a lot of good stuff in there, like BSEPs or MyCrest, and the rating tools from other countries as well. Can you just open them up, try and read and get a feel of what it's all about. Okay, the two documents which I really like is actually there are 2 documents. One is the active and the passive guidebook, by BSEPs. So it tells you how to design building technically. If you use active systems, what do you have to use? For daylighting, how would you do it? So there's a lot of guidance in there. It will help you in terms of designing really good green buildings at the end of the day. Okay. MyCrest, on the other hand, looks into carbon emission of a building. So if you do certain things, it would cause a certain amount of carbon emission, and then you should be able to calculate it as well through MyCrest, which is kind of good. But having said that, both of these are different, so to speak, from GBI. GBI is a rating assessment kind of suite. Okay, so it's different from those 2. The other 2 are pretty much for designing. Okay, so for GBI, again, the materials are there. You can also go online and get even more, and then you need to read up straight from now on. Okay, and then there are some multiple choice questions and whatnot, and then I would highly urge you to answer. After you read up MyCrest, you answer the question. If you read up BSEPs, also answer the question and whatnot. Okay, and there are 3 of those on Spectrum. And then I think let me just share with you the Spectrum page. Show you now. Okay, just now I saw the other people who did not attend sudah masuk. So I'll just put them in. Save, done. So I'll go back to 6109. You can just about see if hopefully you can all fill up this survey, learning attitude survey, and also the course of this survey, just to find out how much amount of information you know. And then all the information about the course is here. And then it's also basic information on green buildings. There's a link to a website you can read up about green buildings. The coursework is here as well. It's been laid out over here. Plus, you can also download the PDF after you click on this. Similarly, the same PDF in the essay and the same PDF in the presentation as well. And then, for your essay, I want you to do a Turnitin check. So you click on this, you submit your document in there, and Turnitin will tell whether or not your document is highly plagiarized or not. If it's more than 20%, it's highly plagiarized. So it means that you've been copying and pasting far too much. You need to put your own words in it. All right. So do proper referencing as well. And then presentation. So upload your PowerPoint presentation here later on. Lectures. And then information about green rating tools. So you've got GBI, you've got the non-residential existing building tool here. You can download it, read it, get a feel of it. Go to GBI website here. We also have LEED from America, Green Mark. Then there's some questions asking you difference between these two. Okay. So my class, the documents are all in this folder. A number of documents in here, you can read out all of them and then answer this question. Next one, you also read up stuff inside BSEPs and answer this question as well, right? This is more about building your confidence, your knowledge about green buildings kind of thing. Because ultimately, it's not just to help you in terms of doing your assignment, but also to help you in terms of completing your architectural design for studio, okay, in year 4, year 5 as well. And perhaps you will carry on your career over your lifetime, because we want to convert you, so to speak, to people who can design green buildings rather than just conventional building. Okay? Even if you do heritage buildings later on, the heritage building too, if you can make it energy efficient, it'll be fantastic. You will sustain it for much longer, okay? Because you love heritage buildings. So what better than sustaining it for a lot longer? Make sure that it's energy efficient so that the occupants love it, and then the occupants will be comfortable inside it as well. So don't just like look at it from a heritage point of view. Look at it from energy efficiency, water efficiency, resource efficiency, for that matter, as well. Still need to consider green building components. And then life cycle analysis, and number of videos here. I want you to learn a little bit of life cycle analysis. What is it about? Technically, GDI is a subset of life cycle analysis. And analyzing the amount of energy or amount of carbon that you emit throughout the life cycle of your building. And then there's another one which is life cycle cost analysis. Okay, so read up and then hopefully you can answer this one. Okay, very simple question, nothing difficult here. And then there are further reading. You can read out about OTPV, how to calculate it. You can also read out about Code for Sustainable Homes from the UK. And then if you like, you can also read out on Japan's rating tool here, and then the MS 1525 I've already included here, and then the electricity tariff from DNB as well. And then at the end of the semester, I hope that everybody can fill out the course exit survey, and that's about it. Okay, so everything is pretty much here now. And then for attendance, don't worry, I'll be taking attendance every time we do the class, like what I did earlier. So I'll be clicking on this and then filling up. Right. So yeah, that's it for today. Any questions? Tak ada, nothing. Alright, if there's none at all, Mustaqim nanti, Mustaqim, Nurin nanti just stop the recording, okay? And then they just share the recording online through YouTube. Reina, nanti later on you just give me from your side the attendance, okay? Just keep it running, okay?
Yeah, okay.
Alright, thank you very much.